I just briefly give you this one today so that we're ready for the big one. Its sequence is going to be the same thing that you probably have seen it in algebra, but the way we're going to describe it is going to be important for us. Okay, in calculus, a sequence is a function. Is a function whose domain is just natural numbers. Okay, so it's going to be the same thing here because we are going to use sequences all through this chapter. Okay, 5.1. Let's see if we get. I want to make sure I get these sections, section 1 at least today, because our job is coming from section 2. But we get one question from this one too. So what is going to be a sequence? Let me just remind you that suppose n is the set of all counting numbers. Okay, it's going to be 1, 2, 3, 4, etc. Okay, this is the set of all natural numbers. Okay, set of all counting numbers or natural numbers. Okay, or counting numbers. This is going to be a popular set for this section. Now a function. Any function whose domain is n is called a sequence. Okay, so then any function, okay, we call it a, b, c, a from n, the natural numbers, to r. So the domain is natural numbers, the range is r, real numbers. We can have, various set. You can have a complex numbers, but in this course, just a real number. Okay, so any function where r is going to be is the set of real numbers, is going to be called, okay, it's called a sequence. So this is a definition of a sequence. It's a function. Okay, example. Example of the sequences, the first one is going to be if, you see the function is defined, a of n is equal to the 1 over n. In calculus, we use f of x because x is free, is a real variables. In this course, we use n because we're just using the counting numbers. Okay, sometimes they tell you n is equal to the 1, 2, 3, but otherwise you can assume it yourself. So if an is equal to the 1 over n, then we have a sequence. Okay, then a over n is going to be a sequence, a function. Okay, this is going to be one of them. Any question? Another one, they're not going to be complicated, but it's not calculus. You're not interested in the limits, okay, conversion, diversion, no. The second one is if a of n, a function, is going to be equal to the, okay, is equal to the -1 to the n. Then n equal to the 1, 2, 3, etc. See, if you want to find it at 1, a of 1, that gives me -1. If you wanted to add 2, a of 2 would be -1 squared, which is 1. Okay, so if this is going to be the case again, we have a sequence. An is going to be a sequence, a function or a sequence. Any question? Now, the important part is a notation that we're going to use in this course. Okay, so what's going to be sequence? Sequence, we use sometimes this type of notation, and sometimes the other notation, like in calculus, Okay, so what's going to be sequence notation? I may talk about A of n, especially when we get to the induction, use P of n, this type of notation. But the other notation is going to be like a function, like a calculus. Now the notation is going to be, look at the sequences, every sequence that we consider, okay, every sequence that we consider, the domain is set of counting numbers. You said the domain is 1, 2, 3, etc. Sometimes you may also add 0 to your collection, depends on what you want to do with your sequence. So since all the domains are the same, so what we do with the sequences, sometimes we identify a sequence by its range, if you like, by the numbers in the range of the sequence. And we use a special notation for that, okay? So this is fine, we are going to use it, but another format is this one. So we emphasize that the domains are the same. Note that the domain of, okay, the domain of any sequence, the domain of any sequence is simply the set of natural numbers, is n. Okay, so what we are going to do, so we can, or one can, okay, so we are going to be denote, we denote a sequence. Okay, we are going to denote a sequence with its values, okay, with its okay, function values or range, function values, okay, or the points if you like, or the points or the values, outputs, okay, in the range of the sequence, in the range of the sequence. Okay, so the point in the range of the sequence is going to be, when you evaluate it, A1, A2, A3, etc. So what we are going to do is we are going to write this notation. You see, if we want to get like a f of x, b of x, f a of n, we denote it by a sub n. Okay, a sub n, or n equal to the 1, 2, 3, etc. But be prepared for both notation. Okay, as I told you, sometimes we use the first one or the other one. So we denote a of n by a sub n. Okay, and this an is going to be called the n terms or the general term. It's called, okay, it's called the nth term, or simply, or the general term, or the general formula, if you like, general form of the sequence. Okay, your first job or your only job in this section is to just write some of these terms for us. Okay, some of the terms of the sequence when we need it. Okay, it's so far it's going to be like algebra. Whatever you did in algebra is the same thing, but we need to review it. Okay, so I'll give you example. So these are the only problems that we're going to have, and we give you one on your next test. We give you the formula for the sequence, and we ask you to list the members. There are two possibilities. Okay, so let's get this one. Would like you to find. Okay, would like you to find the first. Would like you to find the first four. Okay, the first four terms, if you like, four terms of each sequence, with the given general form, with the given general form. So the generator, if you like, the machine, the function, the machine would be given, then you want to identify the term for us. Okay, there are two types. And the first one is just ordinary function, if you like. So you may be given a sub n. It's like f of x. You see, but it's equal to the n squared minus n squared minus 1. And they may list the n, as just to emphasize it, 1, 2, 3. But if they just, an is a sequence which is defined by n squared minus 1, you assume that n can go from 1, 2, 3, etc. Okay, so you are interested in the first term, which is the A1, the second one, A2, A3, A4. So we are going to substitute the n in this formula and get your result, and that will be done. Okay, so the solution is going to be equal to, okay, you start with the A1. A1, all over the places, you replace the n by 1. So that gives you A1 or sub 1 equal to, you substitute, I just substitute the first one so that you know what's going on. It's going to be 1 squared minus 1, which is going to be 1 minus 1. The result would be 0. So the first term of your sequence is equal to the 0. That's the A1. Any question? So you continue to get the others. Okay, we continue to get others. So the other one is going to be A2. A2, you replace the n by 2. So that give what? That give you 2 squared minus 1. 2 squared would be 4. 4 minus 1 is equal to 3. So you declare that your second term is going to be A3. Okay, and you can continue to get the other ones. So I put it here, A3 would be just a 3 squared minus 1, which is 9 minus 1, which is equal to the 8. And the fourth one, okay, for the fourth one, you replace the n by 4. So that gives you 4 squared. Okay, 4 squared minus 1. 4 squared would be 16. 16 minus 1 is equal to the 50. So the terms of your sequence are going to be what? We get a 0, 3, 0, 3, 8, 15, etc. So these are going to be the first 4 terms of your sequence. Any question? So, you can't miss it. You see that in your next practice one. So this is type 1. But there is going to be another format of the sequences that we are going to talk about it later. We have one section to talk about it. But since we are going to use it in a couple of the nice examples that we are going to have in early part of the chapter, so we are going to bring it up here. And that's why you probably have heard about this one in calculus or in algebra. Sometimes this general term of a sequence an. So we don't have the general formula, but we know that there is a relationship between the terms. That relationship would be, you see, this is going to be the an, the general term. If an is going to be, can be written in terms of some previous terms, if you like. In calculus, we say this sequence is recursively defined. We are going to have 3 sections on this type of sequences. But for the time being, we use it. We use it over here because we need them. But we get to this one later on. But you have to get to know it because we have a couple of examples. We want to have some nice problems before getting to the section 5.7 or 5.6. So that's why we bring this type of the sequences through, just to get to know them. And this is it. You have a sequence an. You don't have the formula, but you know that each term of this sequence is 5 times its per year terms, if you like. So this is an is equal to the 5 times an minus 1. You see? So for example, if you have the A2, it's going to be 5 times the A1. If you want to find the A10, is 5 times the A9. Okay, so they give you this one. They said the sequence is defined by this relation. AN is equal to the 5 times AN minus 1. Then you have to tell you how we're going to check the AN. Okay, so if you replace the, okay, they are going to tell you that. So you have to give you one of the terms. So AN is 5 AN minus 1. And the A1, you see, N is equal to the 2, 3, 4, etc. And then one more condition. The other condition is that you have to give you the first term. A1 is equal to 2. Okay, you know, this we call it recursively defined, something that you do it over and over and over. And as I told you, we are going to have it in one section in future. But this is a very important examples that we are going to use it in when we talk about the mathematical inductions. Okay, so what you're going to do, like the one that you did for the previous problem. So you need 4 terms. So you already got the first one. You see, you already got the first one. So A1 is already given. So the solution is going to be, okay, this is going to be the solution. The solution is that the A1 is equal to 1, is equal to 2. So we're already done with the first term, because you can only start with n equal to 2 in this equation. So we replace n by equal to 2 to get the A2. So what's going to be the A2? A2 is equal to, I write it down for you. So the A2 is 5 times the previous term. It's going to be like 5A. You see, this is 2, it's going to be 2 minus 1, if you like. We don't usually write it down. But to get it, so that gives us a 5A1. Okay, so the second term is 5 times the first one. But what is the first one? The first one is 2. So that gives you 5 times, okay, 5 times 2, which is equal to the 10. Okay, equal to the 10. So you have your second term. So the second term is equal to the 10. Okay, any question? So this can take various format, but this is just the easiest one. Okay, so that's going to be your A2. Now that you have the A2, you can go and find the A3. What's going to be your A3? You see, now you know it. A3 is going to be 5 times the previous term, which is the A2. So it's going to be 5 times A2. But what is the A2? A2 is 10. So that gives you 5 times 10, which is going to be equal to the 50. So your third term is going to be equal to the 50. Okay, and then you can go on and get the next term. So your next term is going to be A4. So A4 is going to be 5 times the previous one, which is going to be A3. Okay, A3, and A3 is equal to the 50. And this is going to be 250. 250, so A4 is equal to the 250. Okay, so the term of the sequence are going to be, we get the 2 the first one, the 10 the second one, then we get the 50 for the third one, and the 250, etc. So that gives you the term of your sequence. And that's it. We don't need anything else from this section 5.1. You have, your assignment is just, a couple of them that you have. They just ask you to check the terms of the sequence. Okay, so we wanted from the notation point of view, so that we'll be able to go on and start talking about that great method that I talked about it.
Can you move up real quick on the notes?
That's it. Okay, so we just want to make sure that you know the notation that we're going to use from now on of the sequences, and just list them. Then we are going to have quite a lot to talk about it. We start with the method of the induction is the thing that you do in computer science, if you like. Sometimes you have to do something over and over and over. You see, if you want to build a building, so what do you need? You need a foundation. You need a foundation. This is the foundation. Then the important part is from the foundation, you have to build the first floor. If you get the first floor, then based on the first floor, you can go to the second floor. As soon as you get the second one, you can go to the third one. Based on the third, you go to the fourth, dot. So if you get to the 10th floor, so you know that in order to get it, you can, if you get to the 10, you know that you can build the 10 from the 9 from the previous one, and the 9 from the 8, the 7, etc. This procedure that we repeat it over and over and over is going to be called inductively procedure, if you like. We call it inductive methods, if you like. And this is the one that we do quite a lot in computer science. So we go up to this for one place, if you like. Then we find out, oh, this formula is nice, is working. So we say, oh, let's work from now on. So what we would like to do in this section is to introduce this type of procedures and give a proof. Okay, give a proof that why this method is going on forever. So basically, a statement would be given to like in terms of we write down in the form of a sequence. A property and a statement would be given that depends on n. So we are going to call that a statement Pn. Pn means the property P is true for every natural number n. That's a Pn. So something is given to you, you want to prove that a statement is true. So the procedure that we're going to do is going to be called mathematical induction. So what I usually do, I don't go to the formula right away because you are going to miss it right away. So what we do, there are some everyday life examples. We're going to work on those examples first, and then step by step, slowly, we get through that. It's a beautiful method. We get the numbers. So I just want to get rid of the sequences so that I have this, and then I give you the mathematical induction on Monday. Any question? So by that time, I should be done with your test. Okay, I promise that I will grade it and give you the result. And then, because this new concept is quite different, then we be with that one up to the next test. We try to finish chapter 5 in 2 weeks' times. Okay, that's it. Any question? Make sure your assignment is submitted. You know that today is the one, and you have up to tonight to submit your assignment. Okay, so have a good one and see you on. Okay, see you on Monday for this great concept that we're going to have. Okay, don't miss anything from chapter 5. Anything. If you do any interview in future, anything serious in your job or in your field, they are going to ask you to find out whether you got the good idea of this method of induction. Okay, and we try the best to give you everything you need. Okay, in Velo, remember that I talked about it, that great computer science engineer. He solved those 2 great problems in linear algebra just using induction. I'll show you how to use that one. Okay, have a good one. Bye-bye.
Thank you. See you Monday.